Hey everybody, welcome back. And just as I promised, this is Mr. Carey, Mr. C, coming at you with a chapter 7.6 bonus video. Super cool, my first bonus video. And this is talking about mixed numbers and improper fractions. Now, before I get started, I do have to start things with a little joke, as you know I kind of do. Well, did you know that 5 out of 4 people have problems with fractions? Haha. I know. No. I know. Oh, stop. Oh, thank you guys. Too good. Yes, no, they do. But the thing with that is only a fraction of people will get that joke. Oh, yes, I know. Oh, thank you. All right, anyway, that's enough for today. Let's get into the actual learning. I had to type it just because it felt weird, just like saying it without like seeing the words. And I realize it sounds like super robotic, me typing and saying it. Whatever, I'm sure you guys will forgive me. Anyway, let's talk about mixed numbers and improper fractions. Now, chapter 7.6, I laid it down for you. When we're converting mixed numbers to fractions, right? Let's do 1 and let's do 1/3, right? I know that looks kind of weird. Is something, that's all this is. 1 and 1/3, right? Okay, 1 and 1/3. The way I explained it, right? So how many wholes do I have? I have 1. So if I want to write the number 1 as a fraction using my thirds, what is that going to be? Well, that's going to be 3/3 plus 1/3 equals 4/3. All right, do another way. How about 2 and 2/6? Okay. How many wholes do I have? I have 2. How can I write a whole as a fraction using 6 as a denominator? Well, I can do 1 whole plus 1 whole plus whatever's left over equals 6 plus 6 is 12, 13, 14. 14, 6. Okay? Now you can do that. And there's nothing wrong with doing that. And I'm going to show you a way where you can use multiplication to solve this a little quicker. Now, I called it a cheat or like a shortcut or any other thing, right? I don't like to call it a shortcut because once you understand what you're doing here, it's not a shortcut. It's a quicker way to do it, right? So I don't like to use the term shortcut or cheat or a cheating way. Like, it's like saying a calculator is a shortcut to using division. You want to do long division, do it all day long. Once you understand how to do long division, unless you're a teacher like me and you enjoy doing it, you prefer to probably use the calculator. All right, so I'm going to break this down for you. I'm going to use the same fractions. I probably won't because I won't remember. That's okay. All right, we're going to use a fraction, and I'm going to show you what we're doing here. All right, I'm going to probably thicken my lead up here just a little bit. We're going to do 1 and 1/3. All right, now I'm going to do this the first way. I'm going to do it with black pen, right? 1 whole is 3/3, and then I have my 1/3 left over. 3/3 plus 1/3 equals 4/3. Okay, what are we trying to find out? Well, we're trying to find out how many thirds I have, right? That's all we're trying to figure out. I just want to write it as an improper fraction. So I'm going to do this in red this time. Actually, I'm going to write it regular, and I'm going to write it in red to show you what I'm doing. Here we go. We're going to use multiplication and adding to solve this. How about what is 1 times 3? 1 times 3 is 3 plus 1 is what? 4/3. Pretty cool, right? All you're doing is multiplying your whole number times the denominator and then adding your numerator. So 1 times 3 is 3 plus 1 equals 4. All right, and then 4, and the denominator always stays the same. If I want to write it out a little bigger to show you, 1 1/3, right? So let's do this in red. Step 1, 1 times 3 equals 3. 3 plus 1 equals 4/3. I mean, that's the shortcut. That's the cheating way, right? Because you already understand what you're doing, right? If you don't understand what you're doing and you skipped ahead to the bonus video, stop what you're doing right now, shut it down, go back to chapter 7.6 and watch the whole 26-minute video, and then come back and then watch the bonus video. Now, clearly, I have no way of knowing if you do that. I'm just hoping that you do that. But I'm just telling you, you're going to get in a lot of trouble if you don't really understand. Not like you're going to go to the principal's office. Like, you're just not going to understand what it means. Like, what this 1 right here, like, what does that 1 mean? What does this 3rd mean? Where do I get 4? Because all I'm doing, right, is just changing my whole numbers into fractions. All right, where this gets kind of like 1/3, 1 1/3, that's pretty easy, right? Where this gets super helpful is when you have like really big numbers, like, oh, I don't know. Let's do 10 7/8. Okay, I don't really feel like, if I want to do it the book way, right, I don't feel like going, there's 1 whole, plus 2 wholes, plus 3 wholes, plus 4 wholes. Like, I don't want to do that. Okay, for the lower numbers that we're doing, it's fine, right? But when you start getting up into 5th and 6th grade, you do not want to sit here and wear yourself out going plus 6 wholes, plus 7 wholes, and blah, 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 blah. So what you do instead is I have 10 7/8. So step 1, multiply 10 times 8. 10 times 8 equals, and I like to write it like this, 80. 80 plus 7 equals, you guessed it, 87, and my denominator stays the same, and I'm done. That is converting a mixed number into an improper fraction, and that, I'll just call it the shortcut way. I don't like to call it that, because once you understand that this is nothing more than 8/8, 10 8/8. Once you understand that, and I'll draw it out and show you, right? Fine, I don't care. I got nothing but time right now, right? And then I have 7/8. I mean, that's all you're doing, right? I'm just taking these 10, and I'm going 8, 16, 24, 32, 40, 48. Now you're testing my math, right? 8 times 2, 3, 4, 5. 8 times 6 is 48. 8 times 7, 50. 8 and 7, 56. 8 and 8, 64. 9 and 8, 72. And then 10 and 8 is 80. 10 and then 80 plus 7 is 87, right? And then you get the same answer I did. All you're doing, as you can see, why am I multiplying it by 10, right? Because I have 10/8. 10/8. 10/8 is 80, right? And then just add your 7. That's your remaining fraction. Now, that was never explained to me. It was just like, yeah, just multiply and add. And it never dawned on me until like the past couple years where it's like what I'm really doing, right? I'm taking my 10 8/8 and I'm just multiplying. I'm using we use multiplication for everything. Why would we not do it for fractions? We will, and we are. So 10, and I realize this looks like a hot mess right here. 10 times 8, 10 times 8 eighths equals 80, plus my 7 eighths gives me 87 eighths. All right, let's do another one. And it's gonna delete that. That's fine. Fine. All right, let's do something a little. Let's do 5 and 6 sevenths. Okay, here's another example when I don't want to do 7 sevenths, 7 sevenths. I mean, I can, right? I'll do it up here and show you. It's fine. So my whole number, right, 5, how many sevenths do I have? I have 7 sevenths, and I have 5 of them. So here's 7 sevenths, plus 7 sevenths, plus 7 sevenths, plus 7 sevenths, plus 7 sevenths. There's 5, done. And then I have a 6 sevenths laid out. Isn't there like an easier way we could be doing this? Sure it is. I just showed you, but I'm going to show you again right now. 7 plus 7 plus 7 plus 7 plus 7 plus 6. 7, 14, 21, 28, 35. 35 plus 6 equals... 35 plus 6 gets me 41 sevenths. Now, there's got to be an easier way, right? Do we do 7 plus 7 plus 7 plus 7 plus 7, or do we do 7 times 5 or 5 times 7? I mean, that's exactly what we do. So let's do it that way then, right? 5 and 6 sevenths. What is 5 times 7? Equals 35. 35 plus 6 gives you 41 sevenths. I get the same exact answer, but I'm using multiplication. There's a reason why I don't teach this first, because it's a shortcut way. If you don't understand that your whole number here is nothing more than 5 and 7 sevenths, it's going to confuse you. Okay? Now, I mean, you can do this with any mixed number to convert it to an improper fraction. Now, what about the other way? That's a good question. Let's go the other way here and have an improper fraction. Let's start off easy. Let's do 16 sevenths. Now, I don't really want to draw that out right now. Let's start even smaller. Let's do 5 halves, 5 seconds, 5 halves. Now, in the book way that I taught you, all you're doing is decomposing your fractions. So how many halves do I have? Well, I have 5 of them. 1 half plus 1 half plus 1 half plus 1 half plus 1 half. Okay? And then now you count up your wholes. Well, what makes a whole? Well, 1 half and 1 half is a whole. 1 half and 1 half is a whole. And then I have my little 1 half here all by himself. So, how many wholes do I have? Well, I have 1 plus 1 plus 1 half, which is the same as 2 and 1 half. Now, if only there was an easier way to do this. Well, guess what, folks? There is. And I'm going to show it to you right now. Now, at this stage, right, 5 halves or 5 thirds or 6 halves, it's easy enough to decompose and go 1 half plus 1 half plus. That's fine. When you start getting into these big improper fractions, that's going to drive yourself crazy decomposing into unit fractions. Remember, this is always a vocabulary, unit fraction. Right, you could do that, and if you start getting into really large improper fractions, you're going to drive yourself crazy. So don't do that. Let's do it this way. Now, I have the number 5 halves. Now, we don't think of fractions as a division problem. But guess what? A fraction is nothing more than a division problem. It's I'm going to wait for the right? It is. It is nothing more than that's all you're doing is a division problem. So when you are dividing, all you're doing is, have you ever gone to a party and when you cut up a piece of cake, what are you doing to the cake, right? I'm cutting it up into fourths. or I'm dividing it into fourths. That's all a fraction is. Now, I'm sure many of you don't go in and talk to your parents and say, "Hey, Mom, can you divide me up a piece of that quesadilla or that piece of pizza?" Maybe you should talk like that. I don't know. Anyway, so when I am doing this, right, let's go over our terminology, our vocab. Denominator and numerator. Now, the cool thing with this is I'm going to start channeling some chapter 5 stuff, right? Interpreting remainders as fractions. All right, and if you didn't remember that, I'll stop what I'm doing. Go back to chapter 5, go look at that, that lesson, interpreting remainders as fractions. Now, this is what we're going to do. When you are dividing fractions, all you're doing is the denominator into the numerator. I'm going to show you how this works. And your answer, you're going to have the number. I'm not going to put the number sign because I don't want any comments like, why'd you put a hashtag on there? Well, I didn't, fine. But whole number, and then if you have any fractions, remember it's your remainder over your denominator. I'm going to take a minute for that to sink in. I mean, what do you think? I mean, I don't know if you've ever seen this, but that's pretty cool, right? Thank you. I thought it was pretty cool too. But let's see that in action, right? Let's see what that looks like. So we agree that 5 over 2 was nothing more than 2 and 1/2. We agreed with that, right? I have 1 over 2, 2 over 2, 3 over 2, 4 over 2, and then 5/2. So that was our answer we got, 2 and 1/2. Let's see what this looks like when I start throwing down some division skills right here. All right. Now remember, denominator divides into the numerator. Your answer will be a whole number. And then if any remainder you have goes on top, remember remainder on top, and your denominator is on the bottom. So let's see what that looks like. All right, I'm going to erase that. I don't want to erase that whole thing. I don't know why it lets me do that. That's fine. We'll just erase this. All right, and let's check it out, right? All right, denominator into the numerator. How many times can 2 go into 5? Or how close can I get, right? I know 2 can't go into 5. 5 can't be divided by 2. But how close can I get, right? 2 times what gets me close to 5? 2 times 2. Okay. 2 times 2 equals 5. And now we divide, multiply. 2 times 2 equals 4. Subtract. 5 minus 4 is 1. And then my remainder, remember, remainder on top, denominator on bottom. And look at that, folks. That answer is the same as the long old way that we did it. No. No. It's nothing. No, it's nothing, right? I mean, that's an easy one. I appreciate you guys giving me all that, that applause. Really unnecessary. But let's see what that looks like on a larger improper fraction to really make it worth your while. Let's do something like if you have I don't know, 19 fourths. Okay, now can you imagine having to write this into unit fractions? Do you really want to do that? I don't want to do that, but let's go ahead and, we'll start this, right? We'll check it out. So if I have 19 fourths, I have to go, I have 1/4 plus 1/4. I got to do this 19 times. You guys want to see me do this 19 times? No, I don't, look, okay. I'm not going to do it. I think we all understand that 1/4 plus 1/4, I have to do that 19 times, and there's one of my holes, right? I don't want to do that. So I'm not going to do that. Everybody calm down. So what I'm going to do instead is I'm going to do my denominator divides into my numerator. So 4 times what gets me 19? Or 19 divided by 4 is what? The closest I can get is 4, right? Because 4 times 4 is 16. 4 times 5 would be 20. That's too big. Let's go with 16. 4 times 4 is 16. 19 minus 16 is 3. And guess what? My remainder goes on top. My denominator goes on the bottom. And now I have converted 19/4 into 4 3/4. Right? Not too shabby, is it? Thank you. No, I mean, that's not too bad. But anyway, these are your shortcuts, right? And I call them shortcuts. I don't think they're shortcuts. All you're doing is using multiplication and division, which we taught you in chapter 3 and 4 and 5. And you're just doing it to fractions, right? You're making your life a little bit easier once you understand how this works. Anyway, let me know if you'd like this little bonus video. Trying to kind of keep it real for you guys. And yes, there's the book way. I'm going to show you the book way. I'm going to show you the Common Core way, right? I believe in it. But then I also need to show you, like, there are faster ways to do it once you understand Common Core and what we're teaching. So anyway, this is Mr. Carey signing out. Chapter 7.6 bonus video. If you like it, fantastic. Give me a like. If you want to see more, well then subscribe, right? I am putting out videos, maybe not every day, but anytime I'm teaching and I see, my students are having a little of a hard time, I want to throw something in there and, try and help them out. And by helping them out, I'm helping you out. You want to see something? Leave a comment. Let me know. Mr. Carey, I want you to drop some, I don't know, fractions into decimals. I want you to drop some more division. Mr. Carey, I don't understand rounding. Like, just drop it down there. Put a comment there. Let me know, and I'll throw it up on YouTube. Until then, Mr. Carey, Mr. C signing out. Have a fantastic day, and I will see you all later. Where did that go? Ooh.